Hello guys, I wish you a very good evening to all of you. धीरे धीरे ज्वाइन हो जाओ सब लोग. Then we'll start our class. Before starting, just let me know whether everything is clear or not. Audio, video, सब कुछ clear है कि नहीं है. So today we'll be discussing radiation from a moving charge, and in addition to that, we'll first discuss retarded potential. Then we'll move forward to radiation from a moving charge. So this class is going to be very helpful for all the preparing students who are preparing for the upcoming CSIR-NET exam. So is everything clear? सारे चीज क्लियर है क्या? सब लोग एक बार बता दो, then we can start. हेलो रोनी, अमित, ऑडियो वीडियो क्लियर है क्या? एक बार बता दो, then we can start our class. Is everything okay? Okay, so today's topic is a topic from the advanced portion, radiation from a moving charge, and this is one topic from electromagnetic theory. Before starting, let me just introduce myself. So my name is Sahin Sorifi and I am a class educator on Unacademy. I have cleared these exams, CSIR-NET JRF, IIT 95, GATE, WBSET exam, and I am currently a PhD research scholar at IIT Delhi. This is our referral code in case you want to join our Unacademy Plus classes. You can join using this referral code, and you can search my profile by searching my name Sahin Sorifi, and you will get my profile on Unacademy. Once you visit my profile, you will see this is the upcoming course. This course is starting from 18th of November. Okay, this is basically a practice booster course for GATE 2021. So for the GATE 2021 exam, it is a 3 months batch course. And this course will be basically problem oriented. Okay, so this course is going to be really very helpful to all the preparing students. It will be a batch course, and this course will be conducted in English, and it will be conducted by 3 teachers, Om sir, Anjali ma'am, and me, and it is starting from 18th of November. So enroll for this course, and if you are not a Plus subscriber, take Plus subscription using our referral code PhysicsHub. Okay, and you can join this course. Other than that, currently these 2 courses are ongoing: a detailed course or complete course, one quantum mechanics every Monday, Tuesday and Wednesday from 9 to 10:30 p.m. and another course is going on, revision course on physical sciences for the NET exam, basically on every Thursday, Friday and Sunday. So these courses are currently ongoing, and if you visit my profile, you will get more courses like detailed course on condensed matter physics. You get a practice course on physical sciences. You get a crash course on most important topics of physical sciences, a crash dedicated course on STR, and complete course on thermal and statistical physics. So you can avail all of these courses by just taking one subscription. So take Unacademy Plus subscription and join my classes, and other than that, a lot of special classes are also there. ओके, सो हम लोग इसको क्लास को शुरू करते हैं. So today's topic is radiation and retarded potential. Firstly, we will talk about retarded potential. Retarded का मतलब यहाँ पे आप लिटरली अगर बोलो तो पिछला, मतलब if you consider a static charge, so let me just describe this. If you consider a static charge, a charge is sitting at a particular place, then no matter what, the effect of this charge will be same at any instant of time. Let's say it's a point P, and if you calculate the fields at this point from this static charge, it will be same every time. Let's say you are taking at 8 p.m., 9 p.m., 10 p.m. Whenever you take this value will remain same. Now the problem arises when the charge starts moving. Like I am considering a trajectory. Okay. Now a charge is moving. Q charge is moving along this trajectory. Now when you are looking at the field or effect of this charge at this point, let's say, so at the time of observation, the effect which you are seeing here is a result of the charge when it is here. But when you are observing this, the charge has already moved to some other point. Let's say at this point. Although you are getting the effect of the charge when it is situated at this point, but at the time when you are observing the effect, the charge has already moved from this position to this position. So the initial position of this charge is known as retarded position. ओके तो अगर मैं बहुत ही सिंपल लैंग्वेज में बोलूँ तो दिस इज द केस. अंडरस्टूड. तो ये वाला कॉन्सेप्ट क्लियर हुआ. मतलब रिटार्डेड का मतलब क्या है. निशान, रूनी, अमित, गुड आफ्टरनून, गुड इवनिंग टू ऑल ऑफ यू. एक बेसिक मैंने आपको आइडिया दिया है रिटार्डेड पोटेंशियल का. ये पहले बताओ, ये अगर समझ में आ गया तो बाकी मैथमेटिकली जब करेंगे हम लोग वो सारी चीज समझ में आ गया. मतलब वी आर कंसिडरिंग ए स्टैटिक चार्ज. सो नो मैटर व्हाट, आप किसी भी टाइम पे यहाँ पे फील्ड कैलकुलेट करो, द फील्ड, द अमाउंट ऑफ द वैल्यू ऑफ द फील्ड, इलेक्ट्रिक फील्ड और पोटेंशियल विल रिमेन सेम. बट व्हेन द चार्ज इज मूविंग, ओके, द इफेक्ट will be observed later. Like because of the position of this charge at this point, you will get some field at this point. But when you are observing the field at this point P, the charge has already left its original position. Okay, so this position is known as retarded position, and the potential due to this charge will be called as retarded potential. So this is the basic idea of this retarded position. So we will just try to take up some comparative approach. So firstly we will consider the static case. The static case. Static case में क्या होता है? We know Poisson's equation in static case, that is grad square V equals to minus rho by epsilon naught. This is for static charge distribution. और वेक्टर पोटेंशियल के बारे में पता है grad square A equals to minus mu naught into J. J is the current density. Okay. Now this is a second order differential equation. This is also a second order differential equation. So these two second order differential equation will have their solutions. Okay. It will have the solution V of R equals to 1 by 4 pi epsilon naught integration rho of R prime by R d tau prime, and this equation will have solution like this. You know this already. Mu naught by 4 pi integration J of R prime by R d tau prime. Isn't it? Let's say we are calling this equations are equation 1. So this is valid when the charge is sitting at rest. So there is no concept of retarded potential here. It's a simple case, you know. So let's say we have this static charge distribution and we are considering some infinitesimal volume here of this charge, let's say d tau, and you know that this is the origin, means with respect to which we set the coordinate of this thing. So the source is denoted by R prime. Okay, the source is denoted by R prime. The field point where we observe the field, let's say that the point is P. The position vector of the field point is given by R, and the separation between the source and the field point is denoted by curly R. I have already discussed this in our classes many times. Okay, so for this kind of case, static case, we got these many equations, Poisson's equation, and the solutions are given by this. Okay, is it clear till now? अभी हम लोग आगे बढ़ेंगे. What will happen to these equations when the charge starts moving? Now, look. Now, electromagnetic waves travels at the speed of light. Okay. So, what will happen in the non-static case? In the non-static case, okay, the present situation doesn't matter. Okay, in non-static case, when the charge is moving, it is not the status. ये lines बहुत important है guys. It is not the status of the source right now. मतलब present situation में जो status है source की वो matter नहीं करता. That matters, but rather its condition at some earlier time, which is denoted by TR. This is called the retarded time. ठीक है, जैसे कि मैंने इस वाले एग्जाम्पल में एक्सप्लेन किया कि जब चार्ज मूव कर रहा है और आप ये चीज देख रहे हो तो इसका जो कंट्रीब्यूशन है वो इस पोजीशन पे आ रहा है, बट एट दैट टाइम द चार्ज हैज ऑलरेडी मूव टू न्यू पोजीशन. सो दिस पोजीशन इज नोन एज रिटार्डेड पोजीशन एंड द कोरस्पॉन्डिंग टाइम इज कॉल्ड रिटार्डेड टाइम. ओके, when the message actually left, when the message left, यहाँ पे मैसेज का मतलब है द इन्फ्लुएंस और द पोटेंशियल और फील्ड, जो भी आप बोलो वो. ओके, सो आप टी आर को कैसे लिख सकते हो? व्हाट विल बी द वैल्यू ऑफ टी आर? टी आर इज सम अर्लियर टाइम. ओके, सो यू सी दिस इज द पास्ट पोजिशन, पास्ट टाइम टी आर. This is the current time t. Okay, during that time the charge has moved this much of distance. Okay, so we can write tr is equivalent to t minus r by c. Okay, where r is the distance, this curly r is the distance from source point r prime to the field point r. ये टॉपिक थोड़ा सा डिफिकल्ट है गाइस, बट दिस इज वेरी इंपॉर्टेंट फॉर योर एग्जाम. ओके, एंड विल सॉल्व सम प्रॉब्लम एंड इट विल बिकम इजी, वेरी इजी. So we have seen the potential, okay, scalar potential and vector potential in static case. Okay, now this was time independent. No, these were time independent. You see there is no dependency of time on these potentials, but when the charge starts moving the potential will be time dependent. Okay, so therefore the potentials will become, potential क्या हो जाएगा, V of RT. This is equals to the, now look, it is not only depending on the position but it also depending on time. This will be equals to 1 by 4 pi epsilon naught integration rho of r prime अभी देखो पोजीशन के साथ साथ इट ऑल्सो डिपेंड ऑन द प्रीवियस टाइम, रिटार्डेड टाइम टी आर बाय कैपिटल आर डी टाउ प्राइम. Just try to compare the two potential. Here it was only function of r prime, but now in addition to r prime, the time factor has been included because the charge is moving. Similarly, the vector potential A of rt will become mu naught upon 4 pi j, which will be a function of r prime tr by curly r d tau prime. Okay, understood? Where this rho of r prime tr is the charge density that prevailed at point r prime at the retarded time tr. देखो इस वाले केस में when the static case is there, the charge density is rho of r only, and because of this rho of r you are getting some influence here. But for the non-static case, the charge density which will be causing the field to appear here, it will be rho of r prime, okay, tr. It will also be the function of time. So this is the concept, guys, of retarded potential. Okay, now let me give you more specifically the mathematical formula so that you can solve some problem. So is there any question? Next we will go for Lennard-Wichert potential. Lennard-Wichert potential for a moving point charge. Okay, so we are just taking up some nomenclature here. So firstly we will consider that W of t, it's a position of q, position of some charge q, position of q, the charge at time t. Okay, so retarded time को आप कैसे रिप्लेस करोगे, r minus omega of tr. Okay, this will be equals to c into t minus tr. Omega of tr is the retarded position. Okay, so I'm just drawing the scenario here. You see, if we are considering the coordinate x, y and g. Okay, and this is the trajectory of that particle. So this is the initial position of the particle, this is the retarded position, and the charge is currently at this point q. This is the present position. And this is the point where we are considering the field. So field will be denoted by the position vector r. Okay, and the retarded position is W of tr. This is W of tr, and this difference from the retarded position to the field point, this is denoted by this curly r. Okay, so we can write this curly r is basically r minus omega of tr. So in this situation, we can write the potential, the actual expression of the potential is given by this V of RT equals to 1 by 4 pi epsilon naught QC upon RC minus R dot V, where V is the speed of the charged particle. So this is the ultimate formula which you have to remember for the exam purpose. Okay, where this V small v is the velocity of the charge, at the retarded time. Okay, and similarly you can correspondingly find out the vector potential A of RT, and which is given by this expression mu naught upon 4 pi into Q into C into V upon RC minus R dot V. Okay, this is equals to basically V by C square into V of R into T. So these two potentials, if you name them, these two potentials, this is 1 and this is 2, these two potentials are known as Leonard-Wishart potential. Okay, 1 and 2 are known as Leonard-Wishart potential. ओके, यहाँ तक सबको सब कुछ समझ में आ गया। बस आपको ये फॉर्मूला याद रखनी है, एग्जाम में अगर आएगा तो आप डायरेक्ट फॉर्मूला का यूज कर सकते हैं। सो इन योर एग्जामिनेशन द वेलोसिटी में बी गिवन और सम अदर सिचुएशन में बी गिवन। आई विल बी सॉल्विंग अ प्रॉब्लम सो दैट यू कैन अंडरस्टैंड। सो these are called Leonard-Wishart potential for a moving point charge. Okay, for a moving point charge. एक प्रॉब्लम कर लेते हैं, और इसका एक अल्टरनेटिव फॉर्म भी है। देयर इज सम अल्टरनेटिव फॉर्म, यू नो, फ्रॉम STR, स्पेशल थ्योरी ऑफ रिलेटिविटी। बीटा इज सम क्वांटिटी व्हिच इज गिवन बाय द स्पीड बाय वेलोसिटी ऑफ लाइट v by c. Then your expression A of RT will become beta into V of RT upon C. So you can utilize any of the formula. Okay. So now let us solve a problem. So the problem reads like this: a particle of charge Q moves in a circle of radius A at constant angular velocity omega. You can assume that the circle lies in the xy plane and also centered at the origin. And at time t equals to 0, the charge is at A0 on the positive x-axis. Find the Leonard-Wishart potential. For points on the z axis. This is the question. Will you be able to solve it? I have already given you the formula. Okay, तो उतना टफ भी नहीं है, कर लो एक बार. Just give it a try, then we can do it. एक ऐसा सर्कल है, ये एक्सवाई प्लेन पे लाई कर रहा है. लेट्स से दिस इज एक्स, दिस इज वाई. A particle of charge q moves in a circle of radius a. तो ये a है, ये 0. At time 0 the charge is at a0, मतलब यहाँ से शुरू किया है वो. So the charge is here at this position. So you have to find out the linear potential per point from the z axis, मतलब perpendicular to this. So how will you solve this question? Can you do it? So for solving this question, what you need? We have to find out linear to that potential. We know the formula. These are the formula. 1 by 4 pi epsilon naught QC by RC minus RB, and this A of RT equals to V by C square V of RT. ये बस आपको निकालनी है, ठीक है. This problem is taken from Griffith's book. देखो Griffith's book से डायरेक्ट क्वेश्चन आते हैं, तो these questions are very important. क्या पता यही क्वेश्चन आ जाए आपके एग्जाम में, ठीक है. So at time t the charge is at, let's say the position is denoted by RT, and it is moving on a circle, so you can write the equation of a circle. A cos omega t x cap plus sin omega t y cap. As it is moving on xy plane and it is making a circle, that is why you can write the position vector of that particle is this. Okay, and you see if you put t equals to 0, you get this position a0. That is why this is the position vector of this particle. So what you need to know to find out the potential, you need to know about the velocity of the particle. So once you know the position vector, we can easily find out the velocity using differential technique. V of t will become how much? It will become omega a minus sin omega t x cap plus cos omega t y cap. Okay, this will be the case. This will be the velocity. Now what will be the position vector? This r will be equals to z minus r, because you have to find out the field at some point on the z axis. So it will be z cap minus the position vector, okay, minus a cos omega t r x cap plus sin omega tr y cap. Okay, as I told you, you have to consider the retarded position. That is why we have taken retarded position. So what we can write from this? We can write r square equals to z square plus a square. Okay, so your r will become root over z square plus a square. So r is found. Now what else we have to find out? So r is found, v is found, so we can just put these values in this equation to get the value of v. Okay, so what will be the value of v? But before that we have to find out this r dot v. तो r dot v निकाल लेते हैं हम लोग, and you can see rc can be taken common, then c can be cut, and this will become 1 minus r cap dot v by c. Okay, so first of all we will calculate r cap dot v. r cap dot v ये क्या हो जाएगा? This will become 1 by r into r dot v. Okay, we know the value of r, we know the value of r, we know the value of v. So if you take the dot product, this will give you how much? This will give you 1 by r into minus omega a square minus sine omega tr cos omega tr plus sine omega tr cos omega tr. Okay, and this will effectively give you 0 because this term we can cancel out. So therefore we can write 1 minus r cap dot v upon c equals to 1. So we have already found out this part. If you take rc common, cc will come, will cut down. So 1 minus r cap dot v by c. So we have already found out this, and that value is 1. So we can write the potential v of r. So v of zt here, because we are calculating the potential on the z axis, it will be 1 by 4 pi epsilon naught q by z. Okay, q by r is z square plus a square, whatever z square plus a square. And if once v is found out, we can easily find out the vector potential A of z equals to basically we have to divide by c square. Okay, v by c square, you have to multiply with v by c square. That will give you q omega a upon 4 pi epsilon naught c square into root over z square plus a square minus sine omega tr x cap plus cos omega tr y cap. That's it. So in this way we can find out the retarded potential. So I have discussed about the theory and I have also shown a problem. Now if you have any question, you can just let me know, otherwise we can move forward to the next topic, which is radiation. So ये वाला थोड़ा छोटा टॉपिक था Leonard Wishart potential and retarded potential के regarding, that we have covered with some problem. So the main thing which we need to consider here are these formulas. ये दो formula आप याद रख लो, because basically एक formula याद रखो तो ही चलेगा. V of RT equals to this, and once you are asked to find out the vector potential, you will just multiply with V by c square, and that's enough. So I hope everybody understood. Now let's move forward to the next topic, which is radiation. Radiation हम लोग शुरू करते हैं. Look, when a charge is at rest, it doesn't radiate. It doesn't radiate. We'll get radiation from a moving charge only. Okay, so we get radiation from either a moving charge, okay, or in fact we should write accelerating charge. The charge must be accelerating to get the radiation. Radiation can be achieved by some accelerating charge or changing currents. You will not get radiation from static current, means the current is, if current is fixed, not a function of time, then you will not observe radiation. So to observe the radiation, you need to have an accelerating charge or some changing current. So then the charge or current will radiate, will show radiation. Now I will be giving you some formula which will be useful for your exam purpose. The formula, just note down the formula. Okay, so give the heading power radiated by a point charge. We'll not go deep into this, we'll just do whatever necessary for your exam purpose. लार्मर रेडिएशन फॉर्मूला, ये फॉर्मूला को आपको याद रखना होगा और इसके बेस पे कुछ क्वेश्चंस आएंगे, वो आप कर सकते हो। सो लेट्स कंसिडर ए चार्ज विच इज सिटिंग एट द ओरिजिन। ओके, तो हम लोग एक कोऑर्डिनेट सिस्टम ले लेते हैं, जैसे दिस इज एक्स एक्सिस, दिस इज वाई एक्सिस and this is your z axis. Okay, now a charge is moving with some acceleration a. So this is the charge q and it is moving with some acceleration a, and we are calculating the field at this point p. Okay, this is the field point, means we are observing the radiation because of this accelerating charge at this point p. So as you know that field point is always denoted by small r, and let's say this line, this position vector is making an angle theta with the z axis. Okay, so the electric field direction will be this. The electric field E and the magnetic field B of an EM wave, electromagnetic wave, due to a point charge, due to a point, ये वाला point charge है, due to a point charge q, okay, having acceleration a at any point p. Okay, this point p, this is the position vector, r is given by, ठीक है, आपका पास एक चार्ज है जो a एक्सेलरेशन से मूव कर रहा है. नाउ यू नो दैट एन एक्सेलरेटिंग चार्ज विल गिव राइज टू रेडिएशन, एंड बिकॉज ऑफ दैट रेडिएशन विल ऑब्जर्व सम इलेक्ट्रिक फील्ड एट दिस पॉइंट p, and that is given by, that electric field will be proportional to, this electric field will be proportional to q into a sin theta by r. I have told you everything. Q is the charge, a is the acceleration, sin theta is the sine of the angle which is made between this z axis and the position vector, and this r is the position vector, and b is also proportional to this q a sin theta upon r, where your theta is the angle which r makes with the z direction. So if this is the electric field dependency, this is the magnetic field dependency, then what will be the pointing vector? Pointing vector, you know the formula, it will be E into B by C square. So Q square A square sin square theta upon R square. And if you write the exact formula, you will get 1 by 4 pi epsilon naught Q square A square upon 4 pi C cube into sin square theta upon r square r cap. So if this is the pointing vector, we can easily find out the total power radiated. Okay, the total power radiated will be given by, इसको इंटीग्रेट करना पड़ेगा ओवर द होल एरिया. ओके, सो द टोटल पावर P will be integration S dot dm, because this S gives you the total power traveled per unit area per unit time. So S dot dA integration, that will give you the total power radiated. That will give you integration, okay, double integration 1 by 4 pi epsilon naught q square a square upon 4 pi c cube into sin square theta upon r square, and the area is r square sin theta d theta d phi, where theta will run from 0 to pi and phi will run from 0 to 2 pi. And if you evaluate this, you will get 1 by 4 pi epsilon naught 2/3 q square a square by c cube. Okay, so this is called the Larmor radiation formula. ये वाला फॉर्मूला बहुत ही ज़्यादा इंपॉर्टेंट है आपके एग्जाम के लिए. लार्मर रेडिएशन फॉर्मूला, इसके ऊपर क्वेश्चन आ सकते हैं. एंड इफ यू वांट टू राइट इट इन टर्म्स ऑफ म्यू, यू कैन आल्सो राइट इट म्यू नॉट बाय 6 पाई सी into q square a square. So these are two equivalent expressions, and these expressions are known as Larmor radiation formula. Okay, so few note is there. So first of all, the Poisson vector r and E is always perpendicular. Always perpendicular. And number 2, acceleration vector r vector and E vector lie in one plane. That is clearly seen from this figure. A, R and E is lying on one plane, and the direction of E and R is perpendicular to each other. Okay, so these many things you have to just keep in mind. That will be enough for you. Now I will be giving you some problem based on this, if it is clear to you. So let me just give you one problem based on this, then it will be more clear to you. So ultimately you have to remember this formula: P equals to 1 by 4 pi epsilon naught 2/3 q square a square by c cube, that is equals to mu naught by 6 pi c q square a square. So this formula is known as Larmor radiation formula. Okay, तो आपके एग्जाम में इसके ऊपर ही क्वेश्चन आते हैं. तो let's solve a problem now. So this is a problem. An electron is decelerated. कोई भी चार्ज जो अगर एक्सेलरेशन डिसेलरेशन कुछ भी हो रहा है तब वो रेडिएशन देगा. अगर कांस्टेंट वेलोसिटी से मूव कर रहा है देन इट विल नॉट गिव यू एनी रेडिएशन. सो an electron is decelerated at a constant rate starting from an initial velocity u, where u is much less than c, means non relativistic case. So u से क्या हो गया, u by 2 डिसलेरेशन हो रहा है, तो velocity will be decreased, during which it travels a distance s. So what will be the amount of energy radiated in time t is. t टाइम में कितना रेडिएशन निकलेगा? You are given 4 options: 3 mu naught e square u cube upon 96 pi cs. Option B, mu naught e square e cube upon 12 pi cs. Option C, mu naught e square u square 6 pi square c square s. या फिर D, mu naught e square into u upon 16 pi cs. So you just apply the formula which I have just told you. This is the Larmor radiation formula. Using that formula, you can easily do this. Okay. Just give it a try using the formula which I have just gave you, and what will be the answer? So you have to find out the total power radiated, total energy radiated. So I'm giving you the hint. The hint is the formula. The total power radiated is given by Larmor radiation formula. Okay, P equals to mu naught Q square U square by 6 pi C. ओके, तो इसमें देखो क्या क्या मिसिंग है, अब क्या क्या निकालना पड़ेगा. सो ये बस फॉर्मूला यूज करना है, बस हो जाएगा और कुछ है नहीं. बताओ कौन सा आंसर मिल रहा है आप लोगों को. So we know the formula power. आपको यहाँ पे एनर्जी निकालना है, एनर्जी रेडिएटेड इन टाइम t. तो बेसिकली p into t, that will be the energy. कर पाओ इसको. सो आपको निकालना है द टोटल एनर्जी रेडिएटेड इन टाइम t. तो दैट इज इक्वल्स टू E, दिस इज इक्वल्स टू पावर इंटू t. सो दिस इज इक्वल्स टू म्यू नॉट एन इलेक्ट्रॉन. सो Q के बदले E बिठाया, E स्क्वायर A स्क्वायर अपॉन 6 pi C into T. ओके, अभी आपको A निकालना पड़ेगा. T इक्वल्स टू क्या है? C नहीं होगा आंसर. हेलो वेनु, C इज नॉट द आंसर एनीवे. A होगा आंसर इसका. आई हैव गिवन यू द फॉर्मूला एंड दिस इज द थिंग यू हैव टू फाइंड आउट. यहाँ पे मेनली आपको T निकालनी है. T कैसे निकालोगे? आपको दे रखा है कि U से U/2 हुआ है, S डिस्टेंस ट्रैवल किया है. यहाँ से टाइम नहीं निकाल सकते. Yes, Lorentz radiation formula. मतलब yes Venu, if you have a charge which is moving with some acceleration a, then it will exhibit some radiation at some point which is situated at some position vector r, and that amount of power is given by 1/4 2/3 q square a square by c cube, that is equals to mu naught by 6 pi c q square a square. This is known as Larmor radiation formula. And we have a problem now. An electron is given to you which is decelerated at constant rate, and the initial velocity was u, and it has become u/2, and during that journey it has traveled a distance of s. So during that travel, what will be the amount of energy radiated in time t? So you know that formula, total power radiated. So what will be the energy? You know the power is energy per unit time. So energy is equals to power into time. So what is unknown here? The only unknown thing here is this time. Time, how can we find out time? you are given the information that the particle electron has decreased its velocity from u to u by 2, and during this process it has traveled a distance s. Okay, so we can utilize this formula v equals to u minus at. Okay, so what is v? V is u by 2, u is u, and a is a. Okay, for the timing let's keep it a into t. So we can write t equals to u by 2a. Okay, so this we can put it here, mu naught e square a square upon 6 pi c into u by 2a. ठीक है, अभी what is unknown here, this one a will cut down, so this is basically mu naught e square into a u upon 12 pi c. Now what else we have to know? We have to know about the acceleration. a वैल्यू निकालना पड़ेगा. a कैसे निकालोगे? We know the formula. What is the formula? s equals to ut minus half at square, you know. Okay, so u into t, you know, u by 2a minus half a t, you know, u by 2a whole square. And what will it give? What will it give you? It will give u square by 2a, and here u square by 8a. Okay, u square by 2a minus u square by 8a. So ये कितना देगा आपको? 3u square by 8a. And from here you can get the value of a. So what will be the value of a? A will be equals to 3u square by 8s. So we have got the value of the acceleration in terms of the quantities given in the question. You see in the question u is given, s is given, and we have only a was unknown here, and we have just expressed a in terms of the known quantities. So we can just replace that to get our desired result. Therefore, what will be the value of e? E equals to mu naught e square into a into u upon 12 pi c. This is the formula. Okay, now we have know the value of a, so we'll just put the value of a here. So mu naught e square upon 12 pi c into u, and a is 3u square upon 8s. So this is equals to 3 mu naught e square into u cube upon r 8 into 12, 96 pi cs, and it is matching with option A. So option A is the correct option for this question. I hope everybody understood this problem. किसी को कुछ पूछना है from this question? Any question from this question? बहुत सिंपल है बेसिकली. u से u by 2 हुआ है, तो ये इस टाइप का क्वेश्चन आपके एग्जाम में एक आ सकते हैं. रेडिएशन फ्रॉम अ मूविंग पॉइंट चार्ज. ये देखो बहुत ही इम्पॉर्टेंट टॉपिक है और ज़्यादातर स्टूडेंट्स इसको छोड़ देते हैं, क्योंकि अगर डिटेल में पढ़ोगे ये तो ये बहुत ही टफ है. दैट इज आई हैव जस्ट चेरी पिक्ड, मतलब जितना आपके एग्जाम के लिए ज़रूरत है मैं उतना ही कराया हूँ, ताकि आपके लास्ट मोमेंट पे उतना हेवी ना हो जाए. अगर नए बच्चे भी पढ़ रहे हैं देन ऑल्सो ही विल बी एबल टू अंडरस्टैंड. Okay, only you just remember this thing, that if a charge is given to you, it is moving with some acceleration or deceleration, it will exhibit radiation, and the power of that radiation is given by this expression 1 by 4 pi epsilon naught 2/3 q square a square by c. Sometimes this relationship are also asked, like if a charge is moving with some acceleration, then what will be the dependency of electric field and magnetic field on theta or acceleration? Then you can say qa sin theta by r, qa sin theta by r. Sometimes it gives you different options, like if the charge is moving with some acceleration a, what will be the electric field? Will it be proportional to 1 by r or proportional to 1 by r square or proportional to 1 by r? क्या होगा? then you can easily see that it is proportional to 1 by r. Okay, b is also proportional to 1 by r, but s, pointing vector, as it is a multiplication of these two things, it will be proportional to 1 by r square. And the total power, you see, it is proportional to the acceleration. So if acceleration is more, अगर acceleration की value ज़्यादा होगी तो power ज़्यादा radiate होगा. Okay, so obvious. So power is directly proportional to the acceleration. So any question? If there is no question, then we can move forward. So guys, time is almost finished. So let me just tell you that there are a lot of benefits of taking Unacademy Plus subscription. Okay, so what are those benefits? You can get daily live classes. You get part and full length tests with the detailed solutions. You get assignments with detailed solutions. You get a proper structured course. You get to cover the whole syllabus. You get a dedicated doubt clearing sessions after every 3 lectures. And PDF of study materials and course class notes are also given. Classes are conducted both in Hindi and in English language. So language is not a barrier, and online classes are conducted. And if you are not able to attend the online classes, like if you miss one classes, you can also watch the offline video recording of that video. It is available for you to watch it anytime. And you also get some WhatsApp support, Telegram support for discussions with other fellow aspirants. So a lot of benefits are there of taking Plus subscription. So join Unacademy using our referral code PhysicsHub. So there are a lot of subscription plan. It's starting from 1 month to 24 months, 1 month, 3 months, 6 months, 12 months. And if you apply this referral code, Unacademy will offer 10% off. So for the time you can take this 3-month subscription or 6-month subscription. The GRADE course is also starting from this 18th of November, so it is going to help you a lot. So thank you guys, thank you very much for joining the session today, and see you in the next class. Bye bye.